All right. Welcome to our February technical seminar for the ISA New Orleans section. Like we said, we're doing a kind of a double header. We did our January session last week, which had to get rescheduled, which was on our first robotics topic, which was really interesting topic, and we had a lot of good interaction with that. And the recording of that is available on our archive page, so you're welcome to go catch that if you weren't able to attend. And today, I don't really have anything exciting to talk about. I'm just going to kind of turn it over to our guest speaker and let him go. But our topic today is, as you can see on the screen, is on IIoT and kind of creating insightful dashboards. And our guest speaker is Tony Trim with the Eaton Corporation. So Tony, take a moment and introduce yourself, and I appreciate you joining us and speaking to us, and I'll let you take it from here.
Yeah, Wayne, I'm glad to be here. I appreciate the invite. Thank you very much. I do wish that I could have got in on the robotics segment on the last session because that's kind of my thing too. Kind of like a robotics head, Raspberry Pi head, Arduino head, all of those. But I guess just quickly about me, I'm Tony Trim, solution architect for Eaton. I guess just to go into my background, I've been in the oil and gas industry for right around 15 years or so, 15, 16 years. I've worked globally, land and offshore assignments in midstream and upstream, in varying roles and responsibilities. I've been from I've been everything from a field technician to a control system software engineer, and I've also been a drilling control systems analytics professional as well. Prior to that, I was, just an electrical technician for Union Pacific Railroad for about 3 or 4 years, working on the electrical systems of locomotives. And going further back, back many, many moons ago, I spent 6 years as a local 716 union electrician. Um, and I just want to emphasize again, I'm really glad to be here, and I hope that we can have a really good conversation going. So, as you can see by by the screen, the topic is industrial insight and how you can, or the benefits of leveraging IoT sensors to create insightful dashboards. Um, One thing is that right now, many companies are beginning to embrace data analytics in combination with IIoT, which is Industrial Internet of Things, and digitalization with the intended purpose of optimizing maintenance practices. Ideally, we all want to increase revenue by reducing operating costs and maximizing production. However, the question is how to foster scalable data-driven decisions. So during this presentation, as I speak today, I encourage you to listen to my presentation, first of all, and think about the value of data science. Think about artificial intelligence and machine learning. And I want you to remember 80% of the value that comes from data-driven decisions uh, are made at scale. And I'll let that sink in for a few seconds. So what I mean by that is that there's not nearly as much value driven from artificial intelligence or machine learning that is actually driven from just basic visualization of your data with basic descriptive statistics like min, max, median, average, and even totals. Just those 4 or 5 metrics can make a world of difference in your application, in your production scenario. So this is where we are at today. So having the infrastructure to collect, aggregate, and display is paramount in any organization's success. And I always say this during every presentation that has to deal with analytics. The more often you step on the scale, the better prepared you are to make data-driven eating and exercise decisions. So, and I say that often, and I change it up how I say it, but more or less, if you don't step on the scale, you'll never lose weight. If you don't step on the scale, you'll never know what steps it takes to get to where you want to be because you don't know where you're at. I know it's kind of silly, but you get what I'm saying. So let's go to the next slide. Let's see here. Okay, here we go. All right. So the topics that we're going to discuss in this presentation, we're going to look at the history of the Industrial Revolution, because you can't know where you're going until you know where you've been, right? Everyone always says that. And plus, I needed a few slides as filler because I can't talk for a long time. All right, Industry 4.0 and IoT, benefits of IoT in industrial applications, intelligent industry in practice, and then we're going to finish it up talking about industrial Internet of Things dashboards. This picture is a little grainy, but really to understand where we are going, it is important to know where we have been. And I said that in the last slide. Over the past few decades, there have been new ways of technology that have emerged, right? You have cybersecurity, you have 5G, you have edge computing, you have big data analytics, you have the Internet of Things, you have artificial intelligence, you have machine learning, and all those are really buzzwords. And aside from cybersecurity, you know, there are different variants of what each of these things can mean. For example, like everyone, you talk to, they'll be like, oh yeah, 5G is great. But do they know why 5G is great? Why is it great? What does it do for us? So just right here, I'm just gonna give you just a brief, how important 5G is with the Internet of Things, with collecting our data, with making sure we get more data to the cloud, is because 5G increases connection speed to about 20 gigabytes per second. It increases the amount of data transfer from one broadband connection to another because of more available bandwidth. Now, apart from those features, right, it offers users the ability to create multiple virtual wireless networks within a single 5G connection. So imagine the possibilities you can if you do that over and over and over, how many devices you can actually get going talking to each other and transmitting data to the cloud. Now, these technologies have helped industry evolve and frankly become intelligent with the ability to capture, analyze, and turn copious amounts of data into, well, how should I say it, into valuable insights that actually are geared towards fueling greater efficiency, efficacy, whatever $50 word you want to use, and innovation. All right, next slide. Yeah, and I kind of chose this slide because it kind of, I like the way it looked. It was pretty cool. Now this right here, I know it's grainy because it's an old picture, that I got off Google, but this is kind of what Industry 1.0 kind of looked like. It was like post, it's like post, picking berries in the forest, but before, but the Model T, somewhere in that range, right? So this is kind of what it was before the late 18th century. Industry was sitting around hand production methods. Next slide. Okay. So here we go, the first industrial revolution, right? So steam and water power led to what is now known as, I guess it would be Industry 1.0 or the first industrial revolution, right? So during the late 18th to the early 19th century, as you can see in this photograph, industry became more mechanized. Innovation fueled the industrial revolution. And let me see, I guess an example of that would be in the textile industry, like we're showing here. You can kind of see it. In the textile industry, new steam and water-powered spindles sent the efficiency of cotton spinning through the roof. So it improved the amount of of output that you can have, and that in itself changed the way things were done, changed how things were done, and really increased. Actually, it benefited people's lives. Right here. This is fun. The second industrial revolution. Okay. This took place probably around the 19th to the early 20th century. People also like to call it the technological revolution. But I think it's where we started to really, utilize some of the principles of physics and things of that nature, right? We really got into the meat of things and understood how to manipulate the things around us a little bit better. So that's when mass production became part of the manufacturing process because of electrification. You know, the electrification of industry. So, innovation such as I guess like the telegraph and the railroad allowed for it actually made the country smaller. It made it easier. It took less time to get products across the country. It took, you know, a few, clicks on your telegraph to send a message across the country. So it allowed for unprecedented movement of people and intelligence, you know, which in itself is a recipe for fueling, is a recipe for furthering innovation. All right, so next slide. This one here, I like this one a lot. Like a computer, but it has like a factory attached to it. All right, so I actually took that picture from a publication called The Economist, and this right here kind of depicts the third industrial revolution. Actually you know, the third industrial revolution is kind of weird because it lasted a really long time. Like actually, a lot of companies are still in that third industrial revolution. And that's kind of what we're fighting against now is trying to move things into the fourth industrial revolution, or what they like to call the coin term, Industry 4.0. But anyway, besides the point. So the third industrial revolution, we're doing it. It's happening now, in the late 20th century, 21st century. This is known as the digital revolution. Um, that's when computers and the internet caused a massive change. Again, the world instead of the country getting smaller, the world got smaller. Industry became more automated. And for those who were listening earlier, when Wayne and I were talking earlier, we were talking about PLCs and people's preferences on which brand to use, Rockwell, Siemens, and in the second revolution, this wasn't even a conversation piece. But now, it's that's like the basic crux of any conversation between two technology professionals. So to be sure with it, industry became automated and people became more connected than ever before. All right. So now let's get into the meat of it a little bit, right? So this is what we're kind of trying to move to now. Now, this picture, I was real deliberate in using this particular picture because, I'm a real big fan of those sci-fi movies and, the dystopic societies where technology has gone so far that it's ruined life on Earth and everything like that. So I thought this was pretty cool because it shows, a human, interacting with what seems to be like an android, right? And you would think that, if you listen to the media and you read certain publications that, we're pretty close to that. We're not. But anyway, just like an innovation of steam power led with the first industrial revolution, innovation also sparked um, the fourth revolution, coined as Industry 4.0. Um, the new technologies that drive Industry 4.0 include um, IoT, cloud computing, machine learning, artificial intelligence, and sensors. Um, I guess, are geared to help the industry ingest, analyze, and exchange large amounts of data. But here's the thing, right? So with this data, it enables organizations to make more informed decisions. Again, increasing their efficiency, uh, safety, and productivity. Now, from the four phases, there are generally right around four phases of the Industrial Revolution, right? We can within those four phases, Industry 1.0, 2.0, those four, there are two key themes that always stay the same. We always see the impact of technological innovation and the importance of connectivity. So if you look at innovation way back when, like prior to Industry 4.0, I mean, no, excuse me, prior to Industry 1.0 or the first industrial revolution, innovation was moving real slow. But once we were able to actually increase communication from long distances and start getting products, to the farther outreaches of where we currently live, you got to talking to more people, and that kind of brings us to around like diversity, two different ideas coming together and pushing technology further. And that's kind of what happened. Like this, if you notice, the smaller the earth became, or the earth becomes, the more ideas are being shared, uh, the increased diversity in not just the interaction or the people that deal with the interaction, but the ideas. It's really fascinating how much, how important it is to be connected in this society today. All right, so the next one. All right, this one is a problem that a lot of companies deal with, and I decided to put in like a pictorial form. So what you're looking at data in silos, right? And it's just kind of stuck there. So, here's the thing, if you ask 10 people, what's IoT? You're likely to get 10 different answers, right? So, on the most basic level, um, IoT is more or less um, the ability to just get everything interconnected and connect to the web. That's the basic definition, right? So again, so like, okay, so on the most basic level, an example would be, imagine remotely monitoring the temperature or lighting in your home, right? So basically all that is just an interconnected web that constantly transmits or exchanges data, um, and it connects different technologies or systems via the web. And the only difference between that and industrial IoT is that we just use industrial sensors. So you just get that extra I out of it, IIoT. Now, let's talk about being siloed. So historically, industry has kept their data in multiple places, mostly databases, or devices, or devices for the purpose of like doing reports and stuff like that, right? Because the main idea was always to be able to create reports based on the data that you have at your facility. Honestly, that makes a lot of sense, and I imagine it's extremely useful. It's scalable to store because the databases, they can just grow and grow and grow, but it's not scalable to interpret, right? So as technology has developed, the amount of data available increased, and there's more or less there's too much to analyze in that same format. And this is where, you know, IoT uses various technologies to enable operators to sort through and harness the data that's available. So I'll put you like this. Recently, with Eaton, we have this IoT enabled MCC that has that's outfitted with continuous thermal monitoring, right? So the problem with that is there's a lot of data being generated that you can look at, but it'll inundate you because there's so much of it, right? So what happens is you look at it, you get a little bit confused by it, and you don't get the full gist of what's going on. So here comes, okay, a dashboard. Okay, so you get this dashboard, and with this dashboard, you're able to have the data aggregated so you can look at it, and as soon as you look at it, you can see what's going on. Because why would you sit there and look at all these temperatures for all these MCC buckets if there's nothing going on? What's the point in that? You want to look at it and see, okay, with one view, within 10 seconds, I can see there's nothing wrong with any of the buckets. But on the other hand, on the flip side of the coin, if something is wrong, you'll see that there's something wrong on one of these buckets within 10 seconds. And then you can spend another minute or two and determine exactly which bucket it is and which connection within the bucket. There's nothing more powerful than that, than to be able to have massive amounts of data come into your system, aggregate it down to where you can find out what's going on if there's a problem in under 3 minutes. So with that being said, Industry 4.0 means massive quantities of data can now be analyzed and transformed into insight or even foresight. And this has a huge impact in the form of efficiency gains, productivity, safety, and better quality. Any questions so far? I know I've been yapping for a while. No? Okay.
Yeah, feel free to unmute and ask a question on the way, or type in the chat if you want.
Yeah. Anyone that knows me knows that I'm a conversationalist. I love to chat. You know, we can chop it up about anything, especially Raspberry Pi. I'm just putting that out there. All right. So, why IoT? Why now? Well, unless you've been living on the rock, you've been watching the news, and I put this little thing right here where it says "help wanted" all over the place. We're begging. I thought that was kind of cool, and that goes back to manpower shortages, right? So we have a shortage of new workers, and they're in trades, or actually at this point, entering anything, right? COVID has forced us to realize that the digitalization of our industrial infrastructure is at this point paramount. Supply chains have become severely compromised due to everything listed here. Manpower shortages, and manpower shortages have led to safety risks. Another thing is digitalization can add in reclaiming unscheduled downtime, manual stop you from having to do manual data collection, decrease your poor operational metrics, and kind of mitigate some of the challenges that go along with having your facilities or equipment in like remote geographic locations. All right. Now, so this talks about this. Here's a little more specific, right? It talks about the challenges, you know, industrial Internet of Things can mitigate, right? And this is really specific to, you know, to industry, right? So these are real life examples from solutions that, you know, have been not necessarily been deployed, but have been proposed. And one thing that organizations, the issues they have these things. They have 3 points. They have latent pains, current pains, and vision pains. So latent pain could be a problem the customer does not know they have, or they know they have it, they just gotten used to it, right? So ongoing motor failures due to vibration. Understand power consumption. Not a few weeks back, late November last year, I was in West Texas, a little town called Kermit, and visited this sand plant. Now, the sand plant, they are powered off of, I want to say, the New Mexico grid, which is notorious for charging really high utility bills. So this one facility, the utility bill was like $300,000 a month. To me, that almost made me pass out. But to them, they're good with it. They're like, well, it's just what we pay. That's it. Just what we pay, you know. So then we're talking about vibration failures. uh, Someone told me one time there was a facility that has like 2,000 motors, right? And then they have four guys who walk around the facility with portable vibration testers or sensors, and they test each motor for 15 minutes. And that's what they do their entire career. Every day they test motors. Every single day do the same thing. But, to me, it seems like a massive waste of time, for four guys to just do that, their whole career, like every month in, month out, that's what they're doing. And then they just recycle and start over. So, yeah, it seems like a waste of time. It seems like there's better ways to do it. But again, like I said, it's a latent pain, right? They just got used to it. All right. So then there's a current pain, a problem the customer knows they have, and they're trying to, figure out a way to to sort it out. And that kind of goes if you look at modernized facilities to connect smart devices. They know it's a problem. They know that they need to, if they want to be competitive, right, then eventually you have to adopt a digital mindset. You have to modernize your facilities. And like I said earlier, you have to step on the scale. And then there's a vision pain, a problem the customer really wants to solve. And that's normally due to what's eating up their pockets the most. So look at outages due to corrosion and worn out equipment. Yeah, they want to deal with that. They want to deal with it quickly. They want to figure exactly how to deal with it. So I guess there's another thing that I want to introduce before I change slides is something I like to call SWOT analysis. Now, when I went to business school, they had a SWOT analysis that talked about internal and external. So your internal is like strength and weaknesses, and your external is like opportunities and threats, right? But what I want, um, what I want to consider is now we are in a different time, right? So it's not just about strength, weaknesses, opportunity or threats. Now it's almost like a SWOT with two S's, two W's, two O's, and two T's. Now hear me out. So you can have your strength, which is internal, but now the big buzzword is sustainability. That's also internal. Every company out there is making some sort of promise by 2030, 2050, they're going to meet some standard, right? And you have your weaknesses, which is also internal, and then there's waste. Your waste has to go along with your sustainability. Then you have your opportunities, which are external. But then the next thing is optimization. If you don't optimize, you can't decrease waste, you can't be sustainable. It all comes together. And then you have threat, right, which is external, which is kind of what your competition is doing, right? But then you also have trends. So if you're not understanding your trends, you're not able to optimize. If you're not able to optimize, you can't cut waste. You can't cut waste, you can't be sustainable. Now, this is my own little thing, but if you want to use it someday, I won't sue you. It's called SSWWOOTT. That's Tony Trim's SWOT analysis. I'm just putting it out there. All right. So now, these right here are more or less some IoT sensor use cases, right? For industrial facilities. And it pretty much monitors a wide range of inputs, both electrical and non-electrical. Um, Industrial facilities, they prefer to have, all these devices networked to a single dashboard or a system. A lot of times, the system that it's connected to is what we would like to call a DCS. DCS is typical with Industry 3.0, which is what we're transitioning out of now, right? So you have your sensors, you have your PLCs, and then it goes to like your DCS system, which could be, just for example, Delta V. I'm not promoting Delta V, I'm just saying, just for an example, Delta V would be like a DCS system that all that would go into, right? So the PLCs would be part of what you would call like the RTU, or the remote terminal unit, which acts as a way to convert the signals from the devices. And also with the PLCs, you can add logic to as well. Now, if you wanted to have the information go to the cloud, it could pretty much be done the same way, but then replacing the DCS system with an industrial PC and some type of router, right? They could route it to the cloud, and it's pretty much the same way. PLC, essentially connected to PLC or the RTU, then it goes to industrial PC, which could be using anything from OPC, UA, Modbus, TCP, in some cases, maybe even Modbus RTU, it just depends. So the benefits of doing, using IoT, industrial Internet of Things type sensors, right, is that, or adopting, Internet of Things, is that data is aggregated and sent to the cloud. You automatically have continuous monitoring. And something that's really important is the fact that you have alarm, state, email notifications. So think about that. Think about, okay, you have this dashboard, right? And you don't look at it every day. You can't possibly look at it every day because you're not like an operator in operations, situation where you're always looking at a screen, right? So it's extremely powerful and time saving to when you have parameters set on when a certain situation would be uncomfortable and you'd like to know about it. So you get a text or an email notification, hey, the parameter you set, we are above that threshold. You should address it. And you get all that without having to sit there and stare at the screen all day long. And you can get that with trip notification. You can get that with KPI asset health. Another thing that's available to you is historical trends. So you get that infamous email or text that says something's broke, and then you have the ability to immediately look at the historical data, trend it out, and see, where's this spike? Where did this happen? And what other parameters or what other metrics seem to correspond with it, right? And then you can do a report. And also something that's interesting too, right? When you have your information in the cloud and it's available to any of your employees all over the world all the time, it's easier to have expert analysis or subject matter experts from anywhere look at the information. And if what you're looking at is a bit out of your purview, like you can see a spike, but you don't know, what it means, right? You can have another guy in Germany look at it, right? It doesn't matter. And you can also get a summary of diagnostics. And another great thing is that a lot of times, not every cloud platform provider has it, but a lot of them do. Like Eaton, I'm just putting it out there. No commercial, but anyway, has a dashboard that we can look at either the web browser or you can look at a phone app. So you can get in the iOS store or even Google Play. Don't be mad at me, Wayne. I did a little shout out. Sorry. All right. Industry 4.0 IoT sensor e-tailer dashboard. So this right here is interesting, right? So you see all those sensors go to a single gateway, right? And you're wondering, okay, they're all going to that gateway. How is that possible? What's going on in that gateway? Because really and truly, the gateway seems like something that's really, really simple. But in actuality, within that gateway, some very important things are happening. Number one, you're extracting the data from your sensors. Number two, you're able to orchestrate which is more or less causing events to happen. Like a program can't run unless you run the program. So something that's always running the program to get your data to come in, right? And then you have the transformation of your data. So the transformation of your data is what happens is when you get your data in, a lot of times it's not necessarily in an easily readable format. So what you have to do, you have to transform it into something that makes more sense to you and can feed right into your front end application, right? And your front end application is going to be your dashboard, right? And then what you have then is you have your loading part of it, right? So you have your, which comes after you transform it. So then you load it into a database, with the right schema. And then from that database, you have an API that goes to a dashboard. So to summarize, within this gateway, you have three things happening. You have extraction, you have transformation, and you have loading. And that pretty much takes the place of the PLC, takes place of or let's just say the RTU. It takes place of the RTU, and it takes place of the industrial PC, and it takes the place of the router. There's all that. Uh-oh, that wasn't supposed to be there. Supposed to remove that. But okay, so all right. So remote monitoring solution, right? Um, right here, what you see is your IoT-enabled equipment or sensors, right? And then, of course, it goes through gateway, and then through the cloud architecture. So what this does it connects your installed base and new devices you need at your facility. It captures the data that was previously stranded at several parts of your facility, which you see here on the left, and pretty much if you use the black box theorem, it does that and brings it to your desktop phone or tablet without any type of like human interaction. So it's more or less a full cloud solution um, integrated with also a customer existing cloud as well. So basically what you're seeing is you're seeing the data. The data is getting generated here. It's pushing through the gateway. It goes to the cloud. From the cloud, it goes to a dashboard. And right here is, where the decisions are made based on that dashboard, based on what's happening. So no longer do you have to have someone going out there and taking specific readings of various things and then going over here and thinking about it. No, it's automated. Okay. Okay, so now you're probably wondering, okay, Internet of Things, cybersecurity is a big thing right now, especially with all the different viruses that are out there and all the things that have happened to various companies. How what makes my stuff safe? Like how can I protect myself, if I implement, you know, IoT sensors and push them into a dashboard so I get insight? How do I keep someone out? Well, the interesting thing about that is um, there are various ways to do it, but again, nothing is foolproof, right? So to battle weak passwords, we'd like to use, or actually, cybersecurity principles likes to use multi-factor authentication, um, which is necessary and extremely successful. So, for example, even if someone is a victim of phishing attacks, the hacker knowing the password is meaningless without a second form of authentication, such as biometric or even a text message that contains verification codes, right? So now if that resources identifier hasn't like so for example, let's say you're logging in, you log into this system, it asks you for your username, your password, right? Um then the next thing it'll do is if you put in the username and password correct, it's going to ask you for a verification code. So even if someone steals your username and password, unless they have, what your secondary authentication is, which is a lot of people, is a text message, then they can't break into the system, right? So the next thing we have right here, we have API security. A lot of times, you also want to have end-to-end encryption, network access control, which is an interesting concept because network access control is similar to like basically turn off like a discovery protocol. So I remember back in the day when I was working with serial communications, you could run like a discovery and you could say, I'd like to look at, Modbus address. I'd like to discover, an active piece of equipment, and I'd like to look between Modbus address 1 and 10, and then it would just keep pinging those addresses and tell you, if there's a device associated with that particular address. And for in some applications, there's also that with TCP as well, where you can run that and see what IP addresses are on a network. Well, it's best to turn that off. If you're going to adopt IoT, it's best to turn that off. And also, it's best to keep IoT off of your network as best you can. So, for example, if you're able to have a gateway that has an alternative way to get to the cloud, that's your best option. Going through your network um, to transmit your IoT data to the cloud, it's a viable option, but again, it's a risk like anything else. Like any device you add to your network is a risk. So if you have an opportunity to segment that, then that's your best option. And then something else that you want to look at is whatever IoT gateway you use, you want to make sure that it's constantly getting software updates, for various cybersecurity patches. And this right here is just kind of like just an image to show you how, you know, important, IoT can be in the process of digitalizing, industrial facilities. Now, let's talk about the relevance in Industry 4.0. So we have streamlined data, machine learning, predictive analytics, equipment monitoring, and we have this 80% thing right here, right? So let me explain it. So how can I put this? Okay, for any modern manufacturing and engineering industry complying with Industry 4.0, some of the most important requirements in the plants are usually streamlined data, machine learning, predictive analytics, and equipment monitoring. That's what you want in your system, right? So an IoT dashboard provides a single platform to connect to all. For example, the elaborations that are displayed on IoT dashboard may shift the maintenance strategy and is followed by many of the stakeholders like the production manager, reliability manager, and I guess even the heads of IT. Now, this 80% thing right here, what I found out is that research study on Industry 4.0 confirms that approximately 80% of industries understand the need to monitor their assets remotely and prioritize the details provided through the IoT dashboard. So to summarize, the main purpose of a dashboard is to interface with physical equipment and human users and operators such that the dashboard encourages, I guess, the organization, the industry, the company, whatever you want to call it, to be more efficient and kind of go along with the human assets and realize the value of the industrial assets. So what a dashboard does is it gives you insight onto not only what's going on with your assets, but like on your industrial assets, but also how your human assets are faring with keeping up with your equipment, right? So if your equipment is failing, it could be you just don't have enough people. It could be you need to adopt a different methodology. It could be you need to stop being reactive and be proactive. It just depends. All right. Now this right here is a little bit sciencey, but just follow me a little bit. All right. So, okay, the human brain can receive 8.96 megabits of data per second, right? But the average person can only comprehend 120 words per minute, like when reading. And I guess that's equivalent to like 81.6 bits of data per second. So as you can see, the difference between seeing like a visualization, seeing a dashboard, and reading, I don't know, a novel or something is mind blowing. It's like 100,000 times difference. So the human brain is wired to visualize fast, not read fast. So I'm saying one more time. The human brain is wired to visualize fast, not read fast. That means looking at a dashboard, you understand a lot more than by looking at a narrative or the same information in the form of a narrative, right? So effective IoT dashboards. So you must have a set of visualizations that can effectively display data from various types of sensors over time. So you can need to have line graphs, gauges, maybe even geographical maps. You need to have summaries, you need to have statuses, you need to have statistics listed. And the charts that really work well are going to be bar charts, pie charts, histograms, even heat maps. All right. So again, the purpose of an IoT dashboard is to provide readable information at a glance for your IoT data. Then like a primary function of an IoT dashboard, must include, I want to say, I guess, the ability to organize that data into an understandable structure, right? And something else that's important with a dashboard, which is interesting, is that it's better if the dashboard is dynamic versus static. So you see this dashboard on the screen right here. It works out a lot better if you're able to move the visualizations in different spots, something that makes more sense to you, right? So for example, when I used to design dashboards for my last organization, one thing that I always did is I had to figure out what's the pattern my customers were viewing, right? And what I found a lot of times was they viewed from the top left to the top right, and then went all the way back down to the bottom left and worked their way all the way to the bottom right. So what that told me was that all my important metrics need to be across the top, like your min, your max, your averages, things along those sort need to be across the top. And then your graphs and your charts that take a little more time to look through, you put those across the bottom. But also, not everyone's the same, so you need the ability to move that stuff around, as the user, right? So as a user, it's important to be able to move or group the relevant data sources together, right? So if you want to have, in this case, all your charts, on the far right, and then all your all your like donut type charts on the far right and all your line charts on the far left, you can do that, right? Also, as a user, the ability to emphasize important really helps to navigate, a complex type dashboard, right? Being able to add emphasis to certain visualizations within the dashboard really helps out. Now, on my end, like as a developer, it really helps to be able to resize because it gives you as a designer the ability to optimize the view. And I'm telling you this because part of it's only part of the problem to get the data, to get the IoT data from your devices to the cloud. That's only part of the problem. The more difficult part is putting it into a dashboard that's generally appealing to the masses. Because if you don't, you can have all the data in the world, but if it doesn't make sense to the viewer, to the user, then it was for nothing. So it's really important that to cover all your bases, you have to have a dashboard that's dynamic. You can't have it static because, again, everyone's different. Everyone likes in different places, and it makes it more user ready. So now, Q&A time. Any questions?
All right, thanks, Tony. Yeah, feel free to unmute, ask a question, or type it in the chat if you don't want to ask it live.
Hey, this is Arthur. Can you hear me?
Yeah. Come on, Arthur. Let's talk. Come on.
Okay. A lot of what you've talked about, everything really is like concepts and things like that. What are the actual products or standards or whatever that would be used to implement everything you've been talking about?
And by products and standards, you mean like specific products? You mean like specific standards? Because the standards are still not fully fleshed out, right? It's still fairly new, but some things that, like for example, getting the data from your remote site, from your facility to the cloud, that does have a set of standards that's pretty much goes along with the architecture of the cloud platform that you're using. Now, as far as products, explain like you want, okay, so I'll put it to you like this, right? Do you have a use case?
No, I'm just thinking in general, like suppose I've got, a whole bunch of sensors and I've got OPC bringing data into a server and it's all there. I say, oh, you know what? I think I want to do some of this IIoT. What would I buy? Who would I call? What would I do to actually implement this?
Well, my heart tells you to call me, but
here's
what you need to do.
What would you do when I called you? I'm just having a hard time visualizing the product, of the software or I guess it's all software really that would generate this dashboard. What is it? Is it commercially available software? Is it something that has to be created for every application?
Okay, so that has a twofold answer. So let's go with your basics. So you have your sensors connected to a server which runs OPC, right? Now that OPC, we can get that data pushed to a cloud platform, and then you can get a dashboard made, right? Now, there are different organizations that could do it for you, but with the core of what you would need is you would need a mirror OPC system or server that you could do an OPC to OPC integration to move the data, right? And then from the OPC that you establish in the cloud, you would have to have an API or a connector that could push the data to a dashboard instance. But again, this dashboard instance you would either have to make it or you would have to contact a third party. Now, if you want to get into more intimate details, I'm sure Wayne can share my information, or I can share my information, and I can really help you flesh this thing out, because that's what I do, right? That's my job. I get data from the client's facility, and I get it going to the cloud, and I don't create the dashboard, but I push it into a dashboard that gives insight similar to what I've been talking about throughout this presentation. So again, that's what I do, and we can really take this thing offline and see if we can figure out how I can help you.
I mean, is the dashboard software, is that something that's a standard product? Like say, an equivalent of say a Wonderware or an RS View. Okay, I've got a dashboard program called X. That's what I'm trying to find out. What is that?
Oh, so the dashboard program. So here it is. So it could be custom made, and it could be a general dashboard application. So for example, you can use a dashboard. You've heard of Power BI?
Nope.
Okay, so Power BI is Microsoft's version of a dashboard application, which kind of takes PowerPoint and Excel, and they make a baby, and it's called Power BI. So, so what you're able to do is you're able to take your information from Excel and push it into a dashboard environment, and create visualizations based on your sensor information. That's one option. Option number two, there's a company called Tableau. Tableau, you also do the same thing. You push the data in this raw form to this dashboard. This dashboard, you can make the visualization yourself. Option three, um, you can, and I don't want to be all commercial or anything, but you can actually go through Eaton, right? And we could put on dashboard as well. So a dashboard is nothing more than a front end application that displays your data. It can either be custom made, you can buy it commercially from several different companies, but at the same time, what you need to be able to get the data to the dashboard. You understand what I'm saying?
Yeah, okay. I just wasn't familiar with dashboard software. That's why I didn't know there was
Oh,
things you could buy that were kind of designed to do that.
yeah. There's stuff you can buy, but you can buy like Power BI, you could buy Tableau, but the trick is to get the information to the dashboard and then to aggregate it properly so you can get the insight you want.
Right. Okay. All right. That's good. Thanks.
No problem. Any other questions, anyone? Because if not, I just would like to leave you with one parting comment broken into 4 parts. So the industry 4.0 pathway, I like to call it monitoring, control, optimization, and autonomy, right? So as far as monitoring goes, you want to be able to monitor your product conditions, external operations, and your usage. And when you're able to do that, then you're able to start to create alerts and notifications for when things aren't going like they should. The next thing is you want control. So you want the software to be embedded in your product or in the cloud. And what you want is to have control of the product functions, or you want to be able to personalize user experience. Now, the next thing, which is kind of my favorite, is the optimization aspect of it, right? So you want to enhance your product performance. And once you do that, then it allows for you to get into features such as predictive diagnostics, services, repair, and so forth. And then last is autonomy, right? And once you get to a really good spot in industry 4.0, and you have these various IoT devices, assets that you're able to communicate with through the cloud, and you can also communicate to each other, and you are able to create that, then you're able to have like autonomous control for self-coordination. So these devices are talking to each other, right? And if you use, the right logic, you can have the device talk to each other. Okay, if this isn't doing and this is doing, this doing. So what happens is you get this self-coordination with other systems, and that can, trigger some self-diagnosis. And if things go really well and the self-diagnosis is correct, you can actually have notifications sent out to your vendors that, okay, this is coming out. I mean, this particular piece of equipment is about to go out, and then you can have a notification sent to your vendor and to your maintenance personnel, and then have them coordinate on when to install it. So there's a lot of possibilities with Industry 4.0. And I know we're getting close to time. Oh, over time. So I just want to thank you for letting me talk, letting me chat, and I appreciate it.
Yeah, thank you, Tony. Really good discussion today. So I appreciate you volunteering, and to Eaton Corporation too for we'll give a shout out to them. And it's okay, you gave a few plugs along the way. It's perfectly fine.
Yeah, I try not to do too much, but
No, you did good. We're cool. It's all good. It's gonna come out. That's the way it is. One of these days I might get like the network bleep sensor here. I could push the button too far or something. No, but it's perfectly fine. So yeah, once again, thanks, and thank everybody else for joining today. And PDHs, I will get them out. I know I'm still behind from last week, but I'll get everybody's out to them, and who have requested them. And nothing on the schedule yet for March, but look forward to some emails once we get that scheduled up. So again, thank everybody for their time, and we'll close it out.
Well, and also before I close, I just want to say that if anyone on the call has, any issues they want to address, or they want to figure out how they can get their facilities into, their facility information into the cloud and get better insight, I'm here. They just share my information. We could talk about it. We could work some things out. I have a whole team I could bring in with me, that can help me to we have the aptitude to pretty much solve any problem. So just give us a try.
Sure, I'll do that. I'll share your contact information with all of our attendees. I usually send out a little follow-up email. So I will send that to them.
All right, thanks.
All right. Thanks again. Have a great day.
All right, ciao.